Alright, now we're going to be getting into the volume and surface area of pyramids and cones. So they're going to be using a lot of the same variables as what we saw with prisms and cylinders. There's some big key differences. Sometimes you need to find a number before you can even plug into the formula. Most of the time with prisms and cylinders, you're given all the numbers that you need. That's not going to be the same thing here. You're going to need to find a number first using maybe Pythagorean theorem, maybe area, maybe perimeter, and then use that number to actually plug into the main equation that you're using for volume and surface. First, I just want to recap, what does volume and surface area mean? Volume is the space filling a shape. Whereas surface area is the space covering a shape. I don't really like using the word space there, because space to me means three-dimensional, which is actually talking about volume. But I don't want to reuse the word area, but it's just talking about covering the outside of the shape versus filling the inside of the shape. So this is talking about inside, this is talking about outside, it's talking about covering each face of that figure. When we talk about the units, let's say we have meters, these would be cubic meters, or meters cubed, or inches cubed. This would be meters squared or inches squared, square inches. We're actually talking about how much stuff will fit inside versus how much stuff will cover the outside. Alright, so again, these formulas are just given to us. You do not need to memorize these. The volume of a cone is 1/3 pi r squared times h. You should recognize part of that formula. This is the formula for volume of a cylinder. So you can see it's just 1/3 of that, which kind of makes sense. It looks a lot like a cylinder. It has the same base, that circle. It's just a cutout of that, so it's only 1/3 of the space that would fill a cylinder. When I talk about the radius, the r, that's going halfway across that circle in the bottom, and the height is going straight up and down from the peak to the center. So the only two variables that we have in there. We're going to use 3.14 for pi most of the time, just because that is what is used on the SOL. Alright, surface area is pi r squared plus pi r L. So it's the same radius as before, still just halfway across that circle, except now the L is not going straight up and down, it's the slant height. It's going down the slope of that cone, so it's still starting at the peak, but it's going down the side of that cone. That is the slant height there that we're going to use. So sometimes we might need to find that, and you can kind of see how we might find that. If we're given the height, and we're given the radius, you have a right triangle there. We just learned about Pythagorean theorem. You can use that to solve for that missing side, which in that right triangle, that would be C, or the hypotenuse, or the longest side of that triangle. So H stands for the height, it's the same, and L stands for the slant height. And they're related by that right triangle. That height, the radius, and the slant height all form that right triangle together, where the slant height is the C in the right triangle. Alright, so let's find the volume of this cone. First, I just want to think about what variables do I really need. So volume of a cone is 1/3 pi r squared times h. So I need the radius and I need the height. This picture's kind of nice, giving me both of those. This is the radius of 11. That 22 is going straight through the middle. That is the true height of that cone. So we can do 1/3 times pi times 11 squared. It's supposed to say squared times 22. That tells us the volume of that cone. Should get that out. 2,686.2 kilometers cubed. That's an enormous cone. So now for surface area, we're going to need to do a little bit more work. So we know we want to use pi r squared, surface area, pi r squared plus pi r L. So we still have the radius, but we don't have the L right now. We have to find that. We're going to have to find that slant height. So we can see that we have the right triangle here. where 11, I would call that the A. 22, I would call that D. That arrow is pointing at this height. We don't have the C in that right triangle right now. So we can do 11 squared plus 22 squared equals some C squared. We're going to add these together and take the square root of that number and find out that the slant height, or L, I'm changing the variable to L, because that's what I'm using in the equation. That is 24.6. I'm just going to round that to the 10. So that's the number I'm going to plug in for L. Pi times the radius squared, which is 11 squared, plus pi times the radius times 24.6, which is what I found for the slant height. Multiply this first part together. Again, actually, you could just type this whole thing into decimals, or solving it one piece at a time. 379.94 is that first part, plus 849.68 for the second part. Total surface area of 1,229.6. That is kilometers squared, because we're talking about covering that shape with little squares. I want you to try the next two on the bottom on your own. Before you try those, I just want to label what you have here. You have the slant height, and you have the radius. So for surface area, you're all good to just start plugging it. Volume is not as good. It's 1/3 times pi times radius squared times the height, which we don't have right now. You're going to need to find that height first. So you have this right triangle. You're going to need to solve for the height there, just so that you can eventually plug it into the volume pool. And the last shape to deal with is a pyramid. The volume of a pyramid is, 1/3 capital B times H. This actually shares the exact same relationship to a prism as a cone does to a cylinder. It's just 1/3 of a prism. So this capital B stands for the area of the base. That base shape can actually change. But for right now, we're only going to be dealing with squares. But that stands for the area of the base, wherever that base happens to be. Here it's just going to be a square. So I would always think about that as length times width, or the side times the side, or a side squared. So we're going to use this formula to find the area of that shape on the bottom. The height is the true height from top to bottom, from the peak down to the middle, whereas in surface area, we're actually going to use the slant height. So, surface area of a pyramid is 1/2 LP plus C. We're actually still going to find the area of that base, but we need some other things. We need the perimeter of the base, which means we're going to add up all four sides of that shape. Again, sometimes it could change, so I kind of want to be general about this. But here, we're just dealing with a square. So the perimeter of a square is 4 times one of the sides, because they're all straight. So for right now, we're just dealing with a square as the base of our pyramid. Again, the L goes down the slope of the pyramid from the peak, down the slanty side of that triangle slope of the pyramid. All right, let's try, we're going to find the volume and then the surface area of that pyramid. I'm going to label what I have. I have the height here. I have the slant height here. The 8 is just one side. It's not labeling the base, it's not labeling the perimeter. It's just labeling one side of that square on the bottom. To find the volume, I need the capital B and the H. Well, I have the H already. That's nice. Capital B stands for the area of the square on the bottom. So I'm going to use length times width. I'm going to do 8 times 8 to find out what that is, 64. Now I have the two numbers that I can plug in. 1/3 times 64 times 9, which gives me a final volume of 192 inches cubed. Surface area, the base doesn't change. I don't need to find that again. That's still 64. Perimeter's a little bit different. That's adding up the 4 sides, or 8 times 4, which is 32. Now I'm not using the true height here. I'm using the slant height, which is 9.8. Sometimes you might need to find that. You can set up a right triangle there. You can kind of see it drawn here. You'd use 9. You'd actually use 4. And then you'd find that that slanty side has to be 9.8. Here, they're kind of nice. They just gave it to us. We're going to find the surface area using 1/2 LP plus B, or 1/2 9.8 times 32 plus 64, and find out that that is about 220.8 inches squared. We're going to do the exact same kind of thing on these bottom two. Actually, on your paper, this is printed out with the 11 written there. That is the true height there. Again, it might not be given to you. You might need to set up a right triangle to actually figure out what that height is or what the slant height is. But on both these, you're given everything that you need. You have the L. You have one side, which is enough to find the perimeter and the base of that square. Try your best to solve these on your own. Again, if you get stuck, ask for help.